Have you ever wondered if you could hop in a time machine and visit the past or future? A captivating thought, isn't it? The concept of time travel has been a staple of science fiction, capturing our collective imagination in books, movies, and television shows. It's a tantalizing idea, the ability to roam freely across the ages, to witness the pyramids being built or meet our future descendants. But beyond the realm of fiction, time travel also holds a significant place in scientific discussions. Theoretical physicists have long been intrigued by the possibility, wrestling with the laws of nature to find a sliver of hope for this fantastical idea. From Einstein's relativity to the strange world of quantum mechanics, time travel has been, and continues to be, a serious subject of study. But is time travel merely a flight of fancy, or does science give us reasons to hope? Well, let's embark on a journey through time to find out. Albert Einstein, through his theory of relativity, gave us the first scientific framework to consider time travel. This idea, once confined to the realm of science fiction, suddenly had a theoretical basis in reality. But what exactly is this basis? Einstein's general theory of relativity, introduced in the early 20th century, revolutionized our understanding of gravity. It depicted gravity not as a force, but as a bending of space and time around massive objects. This bending creates what we perceive as gravitational pull. But the implications of this theory go far beyond mere gravity. It also laid the groundwork for the concept of time dilation, a fascinating phenomenon where time can slow down or speed up depending on the strength of gravity or the speed of movement. Imagine you're aboard a spaceship traveling close to the speed of light. According to Einstein's theory, time would slow down for you relative to someone stationary on Earth. This is known as time dilation. It's not just a theoretical concept either. It's been experimentally verified. For instance, atomic clocks flown in airplanes have been shown to tick slower than their counterparts on the ground. But here's where things get really interesting. If time can be dilated, stretched out, it suggests a malleability to time that we don't experience in our day-to-day lives. It hints at the possibility that we might, under the right conditions, be able to navigate through time, not just along it. To be clear, general relativity doesn't provide a clear roadmap for time travel, but it does suggest that our intuitive understanding of time as a constant, unchangeable flow might not be the whole story. The universe, it seems, might have some temporal tricks up its sleeve that we're only just beginning to comprehend. So, time dilation tells us that time can stretch and shrink, but can we navigate it at will? Well, that's a question that scientists are still grappling with, and the answers they find could reshape our understanding of reality. Onward to the next phase of our journey through time. Imagine if you could take a shortcut through space-time, like using a secret alley in the universe. What an enticing idea, isn't it? This is where we introduce the concept of wormholes. Wormholes are, in essence, a theoretical passage through space-time that could create shortcuts for long journeys across the universe. The idea of wormholes was first proposed in 1915, and its roots can be traced back to Albert Einstein's theory of general relativity. However, it wasn't until the 1930s that physicist Ludwig Flamm, and later Robert Wheeler, took the concept further by suggesting that these space-time bridges could exist naturally in the cosmos. Wormholes are fascinating because they propose a way to bypass the linear progression of time. Imagine this. You're at point A and you need to get to point B. Normally, you'd have to traverse the entire distance, but with a wormhole, you could potentially step from A right into B, as if folding a piece of paper and poking a hole through from one side to the other. Now, you might be wondering, if wormholes are theoretically possible, why haven't we found one yet? Well, the answer lies in their stability. Current understanding suggests that wormholes would be extremely unstable and would collapse quickly, making them unsuitable for travel. However, theorists have postulated that a substance known as exotic matter, which is yet to be discovered, could potentially stabilize a wormhole. But here's where things get even more interesting. If wormholes could be used for time travel, they open up the possibility of paradoxes. For instance, what happens if you go back in time and prevent your parents from meeting? This is known as the grandfather paradox, and it's one of many mind-bending scenarios that arise when we start toying with time. Wormholes could be our ticket through time, but they bring up some mind-bending paradoxes. As we delve deeper into the realm of time travel, we'll explore these paradoxes and more, challenging our understanding of reality as we know it. What happens if you travel back in time and accidentally stop your parents from meeting? This is an example of a time travel paradox. Specifically, It's known as the grandfather paradox. If you prevent your parents from meeting, you would never be born. But if you were never born, how could you have traveled back in time in the first place? This paradox has been a topic of heated debate within scientific and philosophical circles. Some argue that such paradoxes demonstrate the impossibility of time travel. Others suggest that time travel could be possible, but it would be governed by a set of rules that prevent these kinds of paradoxes from occurring. Another well-known paradox is the bootstrap paradox. This involves an object or piece of information that is sent back in time, becoming the very thing that was originally sent back. It's a closed loop with no discernible origin. Where did the object or information come from in the first place? Now let's delve into the realm of quantum mechanics. Quantum mechanics is a branch of physics that deals with phenomena on a very small scale, such as atoms and subatomic particles. It's a world where things can be in two places at once. Particles can become entangled and affect each other instantaneously over vast distances, and observing a system can fundamentally change it. There's a theory called the many worlds interpretation of quantum mechanics, which suggests that each quantum event spawns a myriad of parallel universes. In this context, the grandfather paradox could be resolved. If you traveled back in time and prevented your parents from meeting, you would simply find yourself in a parallel universe where you don't exist. Finally, there's quantum entanglement, a phenomenon where two particles become intertwined in such a way that the state of one instantly influences the state of the other, no matter the distance. Some speculate that this could play a role in time travel or in resolving some of its paradoxes. These paradoxes and quantum effects make time travel a tricky business, but perhaps the universe has more tricks up its sleeve. What if every time you made a decision, a new universe sprouted into existence where you made a different choice? This mind-boggling question is at the heart of the multiverse theory, a concept that has been gaining traction in the scientific community. The multiverse theory proposes that our universe is just one of an infinite number of universes, each with its own laws of physics, timelines, and realities. Now imagine if time travel was not just about hopping back and forth along our timeline, but instead a journey across these multiverses. Fascinating, isn't it? Time travel could potentially allow us to visit these parallel universes, experiencing different outcomes of our choices. Take, for instance, a universe where you decided to pursue a career in music instead of becoming a scientist, or a reality where dinosaurs never went extinct. Every significant decision, every random event, every quantum possibility could create a new parallel universe. In this context, time travel transcends the traditional concepts of past, present, and future. It becomes a voyage across realities, each a different branch on the tree of the multiverse. Here's another intriguing aspect. Quantum mechanics, the science of the very small, has shown us that particles can exist in multiple states at the same time until observed. This phenomenon, known as superposition, is another pillar supporting the multiverse theory. If particles can exist in multiple states, why can't universes? However, it's important to note that these are still theoretical concepts, and much about the multiverse and its connection to time travel remains unproven. But the possibility is tantalizing, isn't it? A multiverse where time is not linear, but a sprawling web of realities and timelines, all coexisting and waiting to be explored. In this view, time travel might not be about altering our past, but visiting different versions of our universe. As we continue to push the boundaries of our understanding, who knows what we might discover? After all, the universe is full of mysteries, and in the multiverse, the possibilities are truly infinite. If you could change the past, should you? This question sums up the profound ethical dilemmas that time travel presents. It's not just about the physics, it's also about the philosophy. Imagine for a moment that you've mastered time travel. You could go back and prevent tragedies, right wrongs, or even just fix personal mistakes. But should you? Altering past events could lead to unforeseen consequences. It's the classic butterfly effect. The smallest change can lead to dramatic differences in the future. There's also the question of free will. If we can travel back in time and change events, do we truly have free will, or are our actions predestined? If the past, present, and future are all equally real, as suggested by the block universe theory, then our sense of free will might be an illusion. From a different perspective, if time travel allows us to change the past, then every action we take could be undone, making life seem like an inconsequential game. Would we become reckless, knowing we could always undo our mistakes? On the other hand, what if we can't change the past at all? This is the concept of fixed time, where everything that has happened will happen no matter what. If this is the case, then any actions we take while time traveling have already been accounted for in the timeline. There are also ethical considerations to think about. If someone uses time travel for personal gain, it could lead to significant imbalances and injustices. It could be used as a tool of oppression, or conversely, it could be used to rewrite history to favor the underprivileged. Time travel raises as many philosophical questions as it does scientific ones, and we're only just beginning to grapple with them. As we continue to explore the possibilities of time travel, it's essential that we also ponder these ethical and philosophical issues. After all, science doesn't exist in a vacuum. It's deeply intertwined with our values, our decisions, and our understanding of ourselves. We're a long way from building a time machine, but that doesn't mean we've stopped trying. Our understanding of time travel is still in its infancy, with many hurdles to overcome. The first of these is energy. Theoretical models suggest that a time machine would require a vast amount of it, far beyond our current capability to produce or harness. Then there's the issue of stability. Even if we could create a wormhole, keeping it open long enough and stable enough for a human to pass through remains a monumental challenge. Furthermore, we're still grappling with the fundamental nature of time itself. Is it a river flowing in one direction as we perceive it, or is it more like a vast ocean with currents and eddies that might allow us to move in different directions? Our current theories offer tantalizing hints but no definitive answers. Despite these challenges, scientists are not deterred. They're exploring new theories and conducting experiments to push the boundaries of our understanding. Some are looking at quantum mechanics, where the rules of time as we know them seem to bend and twist. Others are studying black holes, cosmic entities where time and space become warped. Breakthroughs in these areas could revolutionize our understanding of time and perhaps bring us one step closer to making time travel a reality. For example, if we could harness the power of quantum entanglement, we might be able to send information through time, or if we could understand and replicate the conditions inside a black hole, we might be able to create a wormhole. The future of time travel is also a topic of intense speculation. Will we one day be able to visit the past, or are we destined to remain observers, able to look but not touch? Or perhaps we'll discover that time travel is possible, but not in the way we've imagined, leading us to redefine our very concept of what it means to travel through time. The future of time travel is uncertain, but it's a journey that continues to captivate us. The road ahead is long and fraught with challenges, but that's what makes it such a fascinating journey. So hold on to your seats because the adventure is just beginning. As we've seen, time travel is a complex and fascinating topic that intertwines science, philosophy, and imagination. From the allure of traversing the river of time to the intricate theoretical foundations laid by Albert Einstein and others, time travel captivates our collective curiosity. We dove into the concept of time dilation, a mind-bending consequence of relativistic effects that allows time to tick at different rates depending on one's speed or proximity to a gravitational field. We also ventured into the realm of wormholes, those hypothetical cosmic shortcuts that might, just might, allow for quicker journeys through space-time. We grappled with paradoxes, those puzzling contradictions that arise when we contemplate changing the past. We also delved into the enigmatic world of quantum mechanics, where phenomena like quantum entanglement could potentially play a role in temporal adventures. We contemplated the multiverse theory, a fascinating proposition suggesting that our universe may be just one of an infinite number of realities. Could time travel actually involve hopping between these alternate realities? It's a tantalizing thought. We reflected on the ethical and philosophical implications of time travel. What would it mean to change historical events? And what does this say about our understanding of free will? We acknowledge the limitations in our current understanding and technological capabilities. Time travel, for the moment, remains firmly in the realm of theory and speculation. But who knows what future scientific breakthroughs might bring? In the end, the possibility of time travel pushes us to expand our knowledge, question our assumptions, and dream of what might be possible. So I encourage you to stay informed about ongoing scientific developments in this field. Keep asking questions, keep exploring, and who knows, maybe one day you'll be the one to crack the time travel conundrum. Whether we'll ever be able to journey through time remains to be seen, but one thing's for sure, the exploration of this concept will always push the boundaries of our understanding.